Hello students, I am Praveen Kumar. Welcome to Numerical Methods and Integral Transform course. In this lecture, we are going to be discuss about fitting of a second degree curve, or we can also call it as parabola. Right. So fitting of a second degree curve or parabola. So there are the two different kind of the parabolas we are going to be have. That is, so y is equal to a plus bx plus cx squared. The another similar kind of the form second degree is ax squared plus bx plus c. So by using of method of least square, this method we discussed in the last lecture. So using of that method of least squares, we are going to be construct or write the normal equations. So normal equations, we are going to be write the normal equations using of method of least squares. So this we are going to be differentiate with respect to a, with respect to b, with respect to c. So if you solve that particular thing based on this particular coefficient, we need to be remember the normal equations. Summation y is equal to na plus b summation x plus c summation x square. Similar way, second equation is with respect to b. So therefore b coefficient, we are going to be get a equation as summation xy a summation x plus b summation x square plus c summation x cube. So similar way, there is another one more coefficient c. So with respect to c, if you do, we'll get the normal equation is summation x square y a summation x square plus b summation x cube, x square into x, like that we are going to get x cube plus c summation x power 4. These are the normal equations. So based on the normal equations, we are going to be find the summations of y, summation x square, summation x cube, summation x power 4, summation xy, summation x square y. These are the requirements. Based on these requirements, we are going to be construct the table. So similar way, if you see the second one, so using of the same method of least squares, we are going to be get the normal equations of so summation y. So where a coefficient is x square. So therefore we'll be get simply summation x square y a summation x power 4 plus b x into x square summation x cube plus c summation x square. So similar way, the second equation is where b coefficient is x. So therefore summation xy called a summation x cube plus b summation x square plus c summation x. So using of this c, so we are going to get the third equation as summation y is equal to a summation x square plus b summation x plus nc. So plus nc, like this we are going to be have the equations. Using of that equations, we are going to be construct the second degree curve. So which the curve which is mentioned, accordingly we are going to be consider the particular normal equations. So look at this question. Fit a second degree polynomial to the following data by the method of least squares. So some data is provided, and here so second degree polynomial is provided, but that particular equation which is not mentioned, so that we are going to be consider any one of the previous we discussed the curves. So that's what you can consider any one of the curve. Let we are considering. So let y is equal to, you can consider a plus bx plus cx square. So as I said, there are two curves. Y is equal to a plus bx plus cx square, or we have another curve ax square plus bx plus c. If you observe this, only the change is here, x square quotient a here, where the first equation x square quotient is c. So this same, and where a is a constant variable, here c. So b quotient is always same, whatever the equation you can consider. So you can consider any one of the curve, either the first one or second one. So therefore I am considering the second one. So let us consider y is equal to ax square plus bx plus c. If you consider this curve, so therefore with respect to normal equations also we are going to be use the same normal equations. This we are going to be get using of the method of least squares. So the normal equations are, as I said, the simple trick to remember, a quotient is x square. So therefore we need to be multiply this with x square. So take the summation x square into y, summation x square y, a summation x square into x square x power 4 plus b summation x into x square x cube plus c summation x square. This is what the equation number 1. Similarly, the second quotient is b. This if you differentiate with respect to b, where the b quotient is x. So this x we need to be multiplied with the complete equation. So that we'll get summation xy equal to a summation x square into x summation x cube plus b summation x into x x square plus c summation x. This is the second equation because we have the second quotient. So the third quotient is c. So similarly c quotient is 1. So just you need to be multiplied with 1. Summation y is equal to a summation x square plus b summation x plus nc. So we are going to be find this respect to summations. So after finding the summations, we are going to be substituting this. So solve these equations. We are going to be get a, b, c values. So these a, b, c values we are going to be substitute whatever the equation we consider. That is what we can call it as a fitting of a straight line. Now we'll see, we are going to be construct that requirement table. So as I said, so this is a given data where x is equal to 0, 1, 2, 3, 4, and where y is also given data 1, 1.8, 1.3, 2.5, 6.3. So if you see the equations, if you see previous equations, as I said, summation x square required, summation x cube required, summation x power 4, summation x square y, summation xy, summation y, summation x. These are the requirements. So these requirements we are going to be construct as a table. Look at that is what just we consider these columns. So summation x, sum of all these values, we can call it as summation x. If you sum of all these values, we'll get 10. That the notation we are calling as summation x. Where? So y is given. So this y values. So if you find the sum of these values, that we can call it as summation y. So if you do in the calculator, you'll get summation y. This is 12.9. So where summation x square. So summation x square is square of these each observation. So 0 square is 0 and 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So sum of all these observations we can take it as summation x square 30. So x cube is each observation. So each observation 0 cube 0, 1 cube 1. So 2 cube 8, 3 cube 27, 4 cube 64. So sum of all these x cube values we can call it as summation x cube. So this value is 100. Similar way, summation x power 4 required. So each observation 0 power 4 0, 1 power 4 1, so 2 power 4 16, so 3 power 4 81, 4 power 4 256. So sum of all these observations we can call it as summation x power 4. So summation x power 4 is 354. So in the equation we also require summation xy. So first we need to find the observations. X into y, 0 into 1, 0. 1 into 1.8, 1.8. So 2 into 1.3, it is 2.6. 3 into 2.5, it is 7.5. 4 into 6.3, it is 25.2. So sum of all these observations, the notation we can take it as summation xy, that value is 37.1. So similarly we require summation x square y required. So x square column is there and y column. We need to be multiply each and every element. 1 into 0, 0. 1.8 into 1, 1.8. 1.3 into 4, 5.2. 2.5 into 9, 22.5. 6.3 into 16, 100.8. So sum of all these observations we can call it as summation x square y. This summation x square y value is 130.3. So after finding of all these, we are going to be substitute in this particular equations, right? So we are going to be substitute in this particular equation. As we know, the equation we consider as ax square plus bx plus c. So therefore, the first equation is summation x square y, a summation x power 4 plus b summation x cube plus c summation x square. Just one more time I am writing the equations. So summation xy, a summation x cube plus b summation x square plus c summation x. Third equation is summation y, a summation x square plus b summation x plus nc. So we are going to be substitute the values. So summation x square y, as we know, the summation x square y is 130.3. So first equation 130.3 equal to a is as it is. So summation x power 4. So summation x power 4 is 354. So we are going to be substitute 354 plus b summation x cube. So summation x cube is 100. So we are going to be substitute in the equation number 100 plus c summation x square. So summation x square is 30. So we are going to be substitute. So this is what the equation number 1. Similarly, we need to be substitute in the equation number 2 and 3 also. So summation xy required. So go back to the table. Summation xy is 37.1. So 37.1 equal to a summation x cube. Where summation x cube we know it is 100 plus b summation x square. Summation x square we already know it is 30 plus c summation x. So summation x, so from the table we know it is 10. So it is 10 now. So second equation is done. Third equation is summation y. So summation y is 12.9. So 12.9 is equal to a summation x square, a. So summation x square, as we know, it is 30 plus b summation x. So where summation x is 10 plus c is nc. So where n is nothing but number of observations in the given data. So count the observations 1, 2, 3, 4, 5. So number of observations is 5. So therefore n value is 5. So now we need to be solve this using of the calculator, any one of the scientific calculator. If you solve this, we are going to get ABC values. So if you solve this, we are getting the values is a is equal to 0.55, b value is minus 1.07, c equal to 1.42. So after solving of this, we can have many different methods. So if you solve using of any one of the method, we are going to be get these values using of scientific calculator or any other normal method. We are going to be get these values. So these ABC values we are going to be substitute in the second degree curve. So as we consider the second degree curve, y is equal to ax square plus bx plus c, where a, we know the value of a is 0.55 x square, where b is minus 1.07 x, plus C is 1.42. So this is what a curve which is we generalizing. So we are finding the constant ABC. The process we can call it as fitting of a second degree curve or fitting of a parabola. So the usage of this is advantages if you want to be find any value of y at x is equal to anything. So you can substitute x is equal to 0.1. Just substitute in the place of x. So therefore you are going to be find the y value, either 0.1, 0.2, whatever the value you want to be find at second degree as curve. So using of this curve for the provided data, the data is different, the curve is also going to be get different. So for the data we have constructed the second degree curve. This process is called fitting of a second degree curve. So in this session we discussed fitting of a second degree curve, or we can also call it as parabola. So in the next lecture we are going to be discuss about fitting of an exponential curve.